Good. I will open the files that I've just that I've sent this morning.
I have like question towards like the result we have like because I think um I
Yeah.
feel
Okay. Then please open the document and then show me
okay.
the specific questions.
No, I think I'm just in general asking like what the results supposed to interpret it. How can we interpret it, the results? For example, for my thesis, then we are thinking about like using like the domain in the HUI3 questionnaire to break down and, for example, compare with like saying like with different disease like stroke and MI, we all have the same domain and affecting the same thing, and basically we can subtract it. If they both have this symptoms, we can subtract it down the utility value so that it can be more accurate in general. But I'm just wondering, for the result that were coming from the Markov model, is it Markov?
Yeah, Marco. Yeah.
Markov model. I'm not sure exactly. Like from my understanding, it's just like giving them like a start time and end time, and from what I'm collecting, and you can like help us analysis throughout to become like day one, day two, day three. Like what's the level prevalence for each for each domain? Is that what it is?
Yeah. What's the daily symptom prevalence? Yeah, what's the daily symptom prevalence across all domains? That is what these two steps that I was working on were doing. So at first I did what's the symptom change from when day 1 to day 30, and then when you change that matrix in that R code, you get symptom prevalence across days.
Can you see my screen or it's not showing?
Yeah, I can see it.
Is it this like if I want to try to say um how it works, like how can I explain the results?
Can you please also open the Excel file?
Yeah.
And when you go to stroke, I think it's stroke. Yeah, so
This one or this one?
yeah, that one. So in column V, stroke, sheet stroke, please. Can you please open the sheet stroke?
Yeah.
And then in column V, you had that prevalence across. That one. Column V. So you see those numbers in the column V correspond to the day 1 prevalence of symptoms in a stroke patient. And then at day 30, when you go back to the Word document, at day 30, you have a different prevalence distribution. So we say like at day 1, the distribution of the prevalence of vision at level of 1 was 0.49 or 49%, but in 30 days it decreased up to 73%. Do you see? Yeah.
Is this
So
like
we yeah, so the change is, so the prevalence change that I noticed here is like 23% change in 30 days. So it means that that symptom improves over time.
symptom improve over time? Yeah.
No, the symptom,
severity.
yeah, it does. It does improve. Like your vision improves over time. So and then since you didn't have any data for level 2 and level 4, I couldn't recalculate any changes for those levels.
But isn't it like, can't it do like, for example, I give them like a range, so it won't calculate the level of 2 and 4 at all? Like you wouldn't have any like prediction towards like what's the prevalence supposed to be like for level 2 like that? No.
Can you please repeat?
I don't know, like, is it possible for the model to run like what would the prevalence to be like for level 2 if there's like a
Yeah, it's possible, but then you would need to make a distribution. You need to make an assumption since at the beginning you don't have any data.
So you have to at least have something to predict that level of
Yeah.
Okay.
And then you want to define how those how do those states move across time. You know, what happens with vision level 1? Does it move to vision level 2, or does it stay at vision level 2? You know. So since so since we didn't have any data for level 2, we couldn't say, oh, vision level 2 does vision level 2 decreases, or because it gets better, or because it transits to vision level 2. So we had to make an assumption that whoever is in level 1 remains in level 1 and doesn't deteriorate. At level 2 we didn't have any transition, and for level 3, because you see that from day 1 there is 14% there, and at day 30 there is 12% there. So that means that the symptoms are improved, that less patients stay at that symptom level over time. So the assumption is that it is improving, and we want to see how it improves. So as we don't have anyone in level 2, we suppose they go to level 1, right? Level 4.
Yeah. Another question I have so far is like, if that for say like this model actually run it through and it works, and because I think it works in one or two of the domains, and if it works, then how in terms of like calculating the utility will works. I'm not sure how will that connect to the utility part.
So you will multiply those distributions across time. You will input them in that utility formula.
Yeah, but
that
like,
you showed it.
Isn't like that formula you have to have all the domain to work in order to use that like formula?
Yeah, that's what I'm saying. Like, this is just the matrix for speech and, I don't know, vision and hearing, but for the other domains I didn't have time to make it, so I just sent an example how it can be done.
But like
so yeah, you do have to have those matrices for each of the domain.
But
so this is the matrix. So you say from level 1 to level 1, 100% in that stage, states in that stage until
is this what you're saying, or which one are you talking
about? No, the one that you were just looking at.
This one?
Yeah. So you say from level 1 to level 1, how many patients move from level 1 to how many patients remain in that state during time? If you were at level 1, how many stayed at level 1? 100%. And then from level 2, also they stay in that state. For level 3, 50% of them will move to level 1, and 50% will remain in level 3. Then for level 4, you have that they remain in level 4. For level 5, you have 47% move to level 1, 15% move to level 3, and 37% remain in level 5. And then for how would you explain for level 6?
It just remain it like less people remain in here. Or
How many people remained in level 6?
sorry, what was the question again?
How many people would remain in level 6?
This many people?
Yeah, how many is that?
Doesn't mm,
Yeah, it's in the percentages, so 97%. And how many of them would move to level 5? What would you say from level 6?
like this many people will move to level 5?
Yeah, how many is that?
Uh,
How would you read it?
2.5%?
Yeah.
Yeah.
So that's the reasoning behind. So that's the resulting interval metrics for what happens in 1 month, you know?
Mm-hmm.
And then that code that was sent was supposed to transfer that was happening in a day, you know? That's
Mm-hmm.
not in this word, that's in the code only. And when you get that, when you convert that matrix to the R code and apply the code, then the code gives you the daily distribution.
Is it this one?
Yeah.
How can you do? I just run
You press install.
install. Okay. Do I run it?
Yeah. Just click Command and A to select everything. Click on click there. No. Just click anywhere in that console. So click next to the options, let's say. Or click on line 15. Yeah, that's. And then Command A and then click Run. So then so that's the resulting one is daily transition probability matrix. What happens on a daily basis?
Daily basis?
Yeah.
Let me see. So does that mean like, for example, this level to level 5? Does it mean like this remain in level 5 and this one means like level 5 go to level 1?
Yeah. That means that. And then you will multiply those. You will input those level distribution in that formula to get like a daily utility value.
Like, isn't like for example, like daily utility value is like, this is like the prevalence for for improvement,
daily.
but like in order to count like the utility out, we have to have like an average of what, like an, because like in the end we have to choose one level.
For each domain. Yeah
we have to choose each domain for one level, and like, will the Markov one can do like that, like average for that for a day, or it would just only show like this, then it won't have like an average level for that domain.
It will won't show you the average. You need to calculate it in a separate. I think you need to calculate it in a separate, like it not a model but a regression, where you input these variables, where you input this data.
I think it's like Mark didn't really say much about the coding part, because I already informed, like I don't really know much about the coding, so I just focus on collecting the data and see if it works, and gonna write a dissertation out from it. But like, since I don't really know much about the results, what it's supposed to mean, I'm not sure how can I draw like a discussion towards that. So that's why.
This is not even the results. This is, for me, it's still a method, you know.
Yeah, so I think I'm just gonna, because we don't have time anymore, so I need to try to make a thesis out from it. So I'm just gonna
Yeah.
say what. So my thought about like my thesis, I'm just gonna drop to here, and then after we run the model, then we'll see if that this method can actually count out the utility value out from it, so that we can.
Yeah. It can be like methodologically, you don't have to have a result. It's like the proposed methods for calculating
Yeah, but
the
like
utility.
for the result for now, like we do encounter some errors in some domains, right? So that's why I'm wondering like what's the error would be. Then I can kind of like say it in my thesis, saying, "Oh, this is the error could be, and how possible maybe we can improve that or like that."
Yeah.
Yeah, does that make sense? I'm sorry.
Yeah, it does make sense.
Yeah, so
So,
I'm just trying to figure out like what's the problem for the part that doesn't work out. Then maybe I can find some literature or some.
the thing is, so
Uh-huh.
you see that in that Word document that I sent you, like
Mm-hmm.
you have two ways. It means how you approach to generating this matrix. So you have, I think you
The speech one, speech one. I think that's the one you have to
speech,
approach.
yeah, clinical and proportional.
Mm-hmm. This one, clinical and yeah, this one.
Yeah. So, for example, one one worked in trying to calculate to a daily level, but the other one didn't. So I think the clinical worked and the proportional didn't work.
Mm-hmm.
So if you go to the code again, it's written also in the code.
The code.
Let's go through it.
This one, right? The speech one.
Yeah. Let me just clinical structural approaches. So, can you please just zoom in a bit?
This one.
Yeah.
I don't think I can zoom in.
Yeah. Zoom. Thanks. So, can you please go a bit down? I think there is a comment. Which of them worked and which one didn't? Go. The comment will be in green.
Like this.
Just keep there. Both matrices have eigenvalue 1 with algebraic multiplicity 4. Full, but can you go a bit down?
This is the end.
Yeah. Let me just check on my computer. What did your mentor said? Like, how did that go?
What metric?
What did your mentor said? The professor you were working with on the thesis. What did he or she say about?
Because the problem is like initially like we're trying to run this model and then we can got the calculate utility value out from it, and then we can calculate quality through times and compare it with the public paper. But I don't think that's even possible right now because I have to narrow it down to what the result I have so far. So I need to present like the modeling results in my thesis just to say, okay, so we try this approach to see if we can use like this domain to to like solve the problem of double counting the same symptoms towards the utility value, like contribute to the utility value. And then what Mark was informing me was like just collecting, because we're gonna try to run it in the national health model, but I don't know how would that work either because that's what he said he's gonna help me to do it. And so besides that, I'm not sure the following part how that will be imported into the national health model. I guess it will select randomly in the patients and then just select the patient and just assign them with the level of the severity level of like the symptom they have, and then we can try to run out like a final value for the utility value, and then we can see how was that different from initial methods. I think that's the approach we had at the beginning, but now like we don't know it yet for the back part, so I'm just trying to see just maybe narrow it down to how we use this data set to run Markov model and see what's the result.
It's Markov. Just
Markov. Okay, sorry. For a Markov model and see how the result was at and see what it works and what it doesn't work. Then I can maybe drop a comment, say what was the part that was useful in collecting the data, or what part was like makes sense for the model to run, so that if like in the future people want to do the same approach or something like that, then they can improve that part, or that's the sake. But like I don't really know much about the results and how can I interpret it, so it kind of be a struggle for me that I'm facing right now, so I'm asking for help at that part just to
So do you see my screen now?
Let me stop sharing. Okay. Yes.
Yeah, so actually it's you see that here speech clinical.
Yeah.
So it says valid stochastic daily matrix false, it cannot be regenerated. So actually the proportional one that could be is the one that could be retransformed using this eigenvalue decomposition to a daily matrix. So it's actually that approach of initial calculation of the matrix could work.
So this is the approach that could work, but like is it anything to do with the data I collected to make it work or not work, or it's nothing to do with it?
It's not with the data that you collected. It's the way that you. Well, it has, it's the way how you actually assume those movements across states happen. We don't have enough data to say for certain how those movements across time happen. So you have to make assumptions how they will happen. In that terms, it does have to do with the data, because the data is not comprehensive enough to construct, let's say, a robust transition probability matrix on a daily level.
But like then what can I say it's working or what is not working? We don't know what's working and what is not. Is that what it means? It just like when the model run, then it kind of say like if it works, it works. It doesn't work, it doesn't work. Then we don't know like why.
Yeah, we still don't know if it will work in terms of how many qualities it will produce, and if that's going to be valid when compared to the real world practice.
But because for my understanding is like this is just gonna calculate the level.
So this is just a level. This is just a method to calculate the distribution across the severity stages in each domain. And then this method will be used to calculate utilities. Whether it will work in calculating qualities in terms of whether the qualities that we gain from applying this method and utilities we got will reflect the qualities in real world, we are not sure. This is just at the development phase, let's say.
Yeah, but I think my question was like, so when we are just at the first step of like calculating the level of the domain, it shows error in some part, right? Like for example, speech works, and for example for vision, I believe it's not working. vision or
Yeah.
hearing. Vision and hearing was not working, I think. And what I'm trying to understand was, is there anything that make the vision and hearing not working, and but for the speech to work? I think that's what I'm trying to understand.
Yeah, can you please go back? It is. So it's how you assume those movements in the across the stages happen. So when you can you go back to the
The Word document.
to the Word document? Yeah.
Should I share my screen? Or
Just a moment, please. So the actually what? So you have two different methods of, you know.
do they all apply with the same two different methods, or?
But I didn't check it for each of the domain. You know, I didn't check it for pain and for what else did we have?
Pain.
Can you please? Yeah, can you please share your screen?
Oh yeah, okay. It's not showing. Okay.
Mm.
Yeah, can you see it?
Yeah.
Do you need this one or?
No, the Word document.
This one?
Yeah, that Word.
Yeah. So like the clinical structure and the proportional scenario, it's just like the approach they calculate the data. Is that what it is?
Yeah, just the approach to calculate the movements.
But is it possible to just apply this to all the domains and see if it works, or?
Yeah, I think it is. I think that's the part you can check today if you
Then what was
this one was the clinical. That was from the yesterday, right?
Yeah, that's for the yesterday.
And it didn't work. So try to recalculate using that proportional method. Just to speed it up, you really would need to use either Claude or GPT or any other AI that you are familiar with. But give it two methods. You know, give your data set you have, and instead of that clinical approach, try to run proportional for each of them and see if that will run in that code we have.
So for the successful one for speech, if it works, then what was the result we are getting from that? Just for like
The result was that
matrix.
daily matrix.
And how can that daily matrix be applied to the following parts? It just do we have
to calculate utility value on a daily level,
like an overall like through the distribution, right?
Yeah.
But like the matrix, doesn't it just say like how many people move from here to there, there to there? How can they have like a overall value out from it?
But you have for the first month, and then you will actually need to collect more data, I guess, for the second month and for after a year, how it goes, and to get it, through time, I guess.
no, I think I meant like so we got the matrix for the daily what do you call it? Daily domain level, right? Like a metric for that. Is it
Yeah.
possible to just calculate one value out from it? Just one value out from it? Just one like level. For example, like this matrix tell me like at day one what level is it in level one of like speech domain? Is it possible to do that or no?
Not sure.
Then I don't know, like if it means it works, then it just says like it can be possible to generate like a synchronized data of each day. So like so day one, day two, day three, they can show me like day one, day two, day three matrix for speech domain, and that's what this model was doing for now. That's all.
Yeah.
Yeah. So we can't know like what's the average of daily level from it, or you have to be like a separate thing to calculate.
No, it's definitely a separate thing too.
So the
To be
Mako one just say like if that's possible to form like a unified matrix.
But then you will need to have those matrices for each of the domain. At least that's how I understood it. Maybe Mark had another idea in his mind, but I'm not sure,
Because I think there's like one was for so for my collection you can't really use any of the coefficient like the coefficient value at all because we don't know it, like the daily value for the level for vision, for example.
Yeah, I'm just thinking about. Well, actually, it can also be used. For example, you had collected those values through time, so you can use those distributions to use them even without modeling, to use them in the model and apply them at the specific points in time, and get a quality and get utility and quality in time using those time specific distributions, the ones that you showed in that Excel.
Which one?
Even without doing any data recalculations. So
What can I say about that?
not AMI, but the stroke. So that V column,
E column. Yeah. Here.
Yeah, you can actually get like use those distributions at different points in time to calculate utility value and get time specific utilities to calculate qualities, because you had here initial point and then you had like 3 months and 9 months.
So overall, like the result we got from sorry. So from this one, we can only say like it will works impossibly to calculate the utility value for single domains just using this speech one.
Yeah, you can have that as an example for how to calculate the transition probability matrix on a daily level using that data.
This is also in the Mako model.
Yeah, that feeds into getting the transition probabilities for the Markov model.
For the Markov model. Okay. So we're not sure like what can we do for this too in terms of like later on counting more utility value. Is it possible to just let me think, what was I trying to say? I assume like it can calculate like the utility value for day one for speech domain.
Yeah.
Wait, just a minute.
But so what this transition probability matrix gives you, like, you have your initial state distributions. So let's say 49% have hearing at stage 1 at day 1. And then we got a transition probability matrix that says like the probability of staying in that state is 1. So it means all of them who were at state 1 will stay in state 1. So that's what it gives you, that transition probability matrix.
So
how the movements between those initial distribution will further go on.
So it won't explain why like one will go to, like it just assume like the one in number one won't go to other state, but like the other state may go to number one, or just like throughout the distribution it just calculate the possibility. Sorry, did I ask the right question?
I'm not sure. So the one that we got is just for speech, it's not for all the domains.
Yeah.
So it has, it says, if you're at level 1 at day 1, you will stay 100%. The next day you will stay in that level. That's what that daily transition probability matrix says. If you go back to R, can you please go back to? So that's like what this daily transition probability matrix tells you. And then if you were at the level 2, what proportion of them it was in the level 2, 100% will stay at level 2 because you have that one there, you see. And then at level 3, 99% will stay at level 3.
And this person will go to level 1.
Yeah. For 1 day.
But like for different I get what you're saying. So like
so the distributions. So so let's say at day 1 we had 3% of people at day 1, and then when day 2 comes, people from level 3 will improve, and you will get 8 what is that, 0.83% additional in level 2, and then you will use that another distribution across the stages for calculating utility value in day 2.
So every day the daily matrix will look differently, or it will just look the same, but it's just like
it will look differently.
So
no, sorry, the daily matrix would not look differently.
It just calculated
but
from the day before.
Distribution across those stages will look differently because people would move across the stages through days.
Yeah. And how they calculate it, is it like, for example, like the day 1 they're applying to this matrix and then calculating day 2, and then day 2 they use day 2 and calculating this one to day 3?
So you apply this matrix to your initial distribution, So we have, for example, 49 in level 1, 3 in level 2, 4 in level 3, and etc. And you apply this matrix to that initial distribution, then you get the distribution across stages in day Hi, Sabrina. Time
Hi.
went out. Can you
Yeah.
please just share our screen again?
Okay. Yeah, what you're saying.
So that, at the day 2, you will have a different distribution. Then you apply this transition probability matrix to day 2 distributions, and then you get some movements across states until day 3. At day 3, you again have different distribution across stages, And at each day, you will have different distribution across those severity stages that you will input to that, and the different distribution across each domain that you will eventually input to that utility formula. But
Yeah. So does it count as
So
like how they count it? It's not like for day 1 have that one value and they apply to it. It just synchronize it. If you ask day 2 and they will show you the day two prevalence distribution, like day 2 distribution for each level, and day 3 they'll show you distribution for each level, blah blah blah. That's all.
Yeah, that's all.
So in order to count, like for example, I wanted like day one level out from it. I just count the proportion of the distribution and come out with like an overall value out from it, kind of like that. That's how we use it, and then it will become like maybe like day one for speech domain was level 1, and then I use level 1 coefficients to the formula, and then we try to calculate out from it, and that's it for the utility.
No, at each day you will have the distribution in each stage, level 1, level 2, level 3, level 4. And then each of those distributions will be a coefficient in that formula, right? Do you have that paper in front of you?
Yeah, this one. Yeah, what I'm saying is like we can get like the matrix for day 1, right? For day 1, and then it will shows like the distribution of like what would that day be like what kind of level prevalence for each level, and then for example we use level 1 and we use the prevalence to time with the level and to just get a like overall how that level.
No, you multiply that prevalence by B1. So the B1 will be the weighted prevalence of vision weights and the prevalence. You see, like, let's say at day 1 we have 50% of them in stage 1 and 50% in level 2, and then you would multiply 50 by 1 and 50 by 0.98, sum those two, and that is your weighted B1 that will go into the formula. At day 3 we say like, oh, you have 13 day 1, 13 day 2, and 14 day 3, and then you will multiply 30 by 1, 30 by 98, and 40 by 89, sum those three, and then you will get B1 for the day 2.
Oh, so it's not time this but time this.
Yeah, time B1.
So we got like then overall, so we kind of timed the proportional to the coefficient, and then we got like an overall value for that number.
You will have a daily value for that number for each day.
Because I think how this work, it just because it's the prevalence. But what
I have to go. I really have to go in 5 minutes. So, do you have any final question that we can cover in these 5 minutes?
So if we don't, so for the metric, we just can count like an overall B1 value, like an overall B1 value out from it, and then we put
For
it
specifically for the
For the
code we
domain,
have,
yeah,
it's
for-
B3. It's B3 for the ones that we have.
Yeah. So we can just calculate the B3 and into the formula. That's all we got.
Yeah.
And to
Yeah.
see if that's possible.
Yes.
Okay. And then if we got everything for this and just apply it to it, and then we count like an overall utility value.
Exactly.
But is it possible to just compare the utility value for this one and with, like, for example, we have the utility value for this one, we can't calculate the utility value is it reasonable to say, like, if we use this one to calculate the value and compare with the AMI one and subtract it, if that's a, like, double counting the symptoms, and will it make sense or no?
I don't think it makes sense. Because cross comparison across diseases, it's okay when you calculate qualities. You can compare it qualities because it's not, how to say, it's not disease specific measure, and that's why you can do cross disease comparisons, but you cannot compare, utilities that easily.
But if we apply it to the
If you tried to do that calculation with to apply that to try to apply that method to each of those
like for the code at
domains,
here,
then you could get the beta coefficient for each of them, and then you calculate the utility, if that was the question.
But for example, like the speech, we already think that works. How can I select the data so that it can work for other domain as well? Like,
so you have your data in that big Excel file. So, and then apply the same method of those calculation of transition probability matrix. Just look at the numbers in Excel. Just repeat it. In Excel you also have the calculation. Can you please go back to the Excel? So you have a speech TPM proportional, the sheet. It's the sheet name. Speech TPM proportional. Not clinical, proportional. So everything is linked there. If you try to look at those numbers and see how they are linked with your initial data you collected, then you can apply the same method to the other domains. When you click on cell B6, so you see, it goes back to vectors, the sheet vectors. Which one did it? B6 showed. Goes to speech TPM proportional. So it says sheet vectors E37 cell.
This one?
Yeah, so it links to your stroke sheet V35.
This one?
Yeah. So it actually shows how, based on your initial numbers, the whole calculation was done. If you try to recreate it for every other domain, and then you can say I was able or I was not able to construct the matrix of how you switch through the states in time.
Mm-hmm. Mm-hmm. But I hear it just shows like what was being calculated at here, but just like
Yeah.
only the data we essentially needed, and that's it. And so like the major output from the R is just saying the daily matrix and see if it's possible to make a daily matrix for this domain. That's it.
Yeah.
Okay. Is it possible to do this? And I think my questioning was like, this is like the code for the speech. Is it possible to just switch to some, for example, this I believe is like just coding like the data from this page, right? Is it possible? Is it what it is, or
Wait, just to show you where you input those.
the vectors?
It's not a vector. I don't think it's vectors. It's so.
I think I'm just asking like for the R. Is it?
Yeah. So you have those. You have those vectors in line 14.
Line 14 here. This one.
Yeah. No. Line state names. Wait. A bit down. It says observed marginal distributions from vectors sheet. Go up, 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 up.
This is the top.
Okay. Just a bit down. No. State name, just a bit down. Go down. How come that? So you actually input that transition probability matrix you got in there, you see?
This one? Where was
it? Click Command and F and then try to find the matrix. Let me open the same thing on my computer.
Are you looking for daily metrics?
Yeah, speech matrix clinical, and then you have speech matrix proportional. When you calculate that speech matrix in a method where you have proportional transitions across the states, and then you input that matrix here, you should be able to calculate the daily value.
Are you sharing the screen or?
Oh, I'm not. This one.
So I just switched line 49 to. But isn't like I thought it was coded from the same Excel file, or you do like a separate file for each domain and you like extract data out from it?
You would have a separate file for each domain. Just save it as a separate one. You calculate this in Excel, and then you convert that into the daily values. I really have to go now because I have something to finish. So calculate in Excel, and then you do the calculation in the R to get the daily values.
But what needs to be calculated in the Excel? Like
this matrix.
Is there like an code for that, or?
No, it's in Excel calculation. You have the explanation in Word, how you calculate it
Mm-hmm.
for the proportional redistributions, and then you apply it to the other domains.
Okay. Okay, let's stop here for now. Okay, thank you.
Yeah. Okay, good luck. And I mean, if you, I guess you will have the meeting tomorrow with Mark and Tanya and see how it went.
Okay, thank you.
Yeah, good luck. Bye bye.
Bye bye.